A ship is traveling at 20 miles per hour parallel to a straight shoreline. The ship is 5 miles from shore. It passes a lighthouse at noon. Express the distance s between the lighthouse and the ship as a function of d, the distance the ship has traveled since noon. That is, find f so that we can write s as a function f of d. Now, this is kind of out there as far as what's all kinds of things going on here. Let's just start by drawing a picture, and that should help us. So we're going to start with our shoreline. Here's our shoreline. Okay, it's where the water starts, and here's our water out here. Okay, and we've got a ship that's traveling parallel to that. So here's our ship, and I'm not a great artist, but we'll say it's like a little steamboat. Yeah, there's our ship, and it is traveling. We'll say that direction. And it passes a lighthouse at noon. And so we'll say that here's at noon what's happening, and here's our lighthouse. There's our lighthouse. Again, I'm not an artist. There's our lighthouse, and it passes at noon. And we would like to express the distance between the lighthouse and the ship as a function of the distance the ship has traveled since noon. So this ship is going to continue moving, and it's going to, end up maybe over here somewhere. This distance that it has traveled, we are calling that d. And we want to look at the distance from the lighthouse to the ship, which is, we're calling s. Okay? And we know that the ship is 5 miles from shore. So this distance here is 5. Okay? Now that we kind of have a picture of what's going on here, okay, it says we want s to equal a function of d. So we're really looking for a relationship between s and d. And we see, of course, that we've got a right triangle here. And so we can use the Pythagorean theorem. 5 squared plus d squared is equal to s squared. And of course, we just want s to equal a function, so we need to take the square root here. So s is the square root of 25 plus d squared. You'll notice we took the square root, and generally when you take a square root, you would need to do plus or minus. However, s, as a physical quantity, represents a distance, and a negative distance doesn't make any sense, so we don't need to include the negative. So here's our s, and that's our function. All right, this is f of d is the square root of 25 plus d squared. Okay, next we want to express d as a function of time, t, the time elapsed since noon. So that's just looking at what's happening here. Okay, we know that our ship is traveling 20 miles per hour. And so to get our distance, distance is rate times time. So 20 miles per hour times the time that has elapsed is going to give me my distance traveled. Okay? In other words, that's what g of t is. We want to find g so that d is g of t. So d is g of t, which is 20 times t. And finally, we want f composed with g. Well, f composed with g, the input of g is a time t. Okay, so this is f of g of t. So starting with g of t, that's just 20t. Now we're going to plug that into our function f. So f takes our input and does square root of 25 plus that input squared. And so we have the square root of 25 plus 20t quantity squared. And we can go ahead and square that. We get 400 and then times t squared. So there's our composition f composed with g. We want to know what this function represents. And just looking at this function, we know the input is time, and the output is f. Okay, and f, the output of f is of course s, which is the distance um, from the lighthouse to the ship. And so this composition tells us the distance between the lighthouse and ship as a function of time.